I worked for NASA for 5 years. And now I work kind of as a consultant to them, so I still sort of work for NASA. What I mostly worked on was designing missions to other planets, meaning thinking about the science that we can do at other planets, trying to design spacecraft to go to other planets and explore. A little bit of human space flight, so using the space station to get science done, but generally designing missions to other planets to increase our understanding of the solar system and what makes Earth special. So talk about careers. There's really almost any career you can think of. There's a role for it in space exploration. When you think, people typically think of engineers and scientists, but the space world needs creative people. It needs financial people. It needs people. So people who are good with other people, because a lot of scientists and engineers need help actually communicating their ideas to other people. So whether you're good at math or not, there's a place for you in the space exploration field, and I'm happy to see you're interested in it, because I can't think of anything more interesting to work on for my career in my life. So I'm happy to see you all interested. I don't really want this to be like a career day, because I think that's less interesting than what I can share with you. And if you're in third grade, you don't really have to think about your careers just yet. I would rather see you all get really excited about something, and it looks like at least some of you are excited about space. So can someone tell me what planets they've been studying?
Raise your hands.
Wow. Yes, I can't answer. I can't pick the
I've been studying Venus.
Venus, okay. Someone else?
Uranus.
Okay.
Neptune.
Okay.
And one more.
Moon.
The moon.
The moon. Okay, so what I'm seeing is that some of you guys have been we basically talked about all the planets. So what I think the best thing I can do for half an hour, and please correct me if this is not what you want, we can talk about all the planets briefly, and then talk about the missions that went to them, and the spacecraft, kind of get a really quick summary of all of planetary exploration in history. We can do that in about half an hour. And I could, sorry?
I think we got thumbs up. Everybody.
Okay, great. So let's start, because there's a lot to talk about. So first we're going to start with the sun. Sun. Can you all see that?
Yes.
Okay, so can someone tell me, can you land on the sun?
No.
Okay, too basic of a question. So the reason you can't land on the sun is it's a giant ball of gas, and there's so much gas, and it's so heavy that the gravity between the actual little pieces of it, the actual molecules, is so great that it compresses them, and they undergo something called fusion, which releases the energy that we get from the sun, and that's what happens inside all stars. So the sun is releasing light and energy and heat all the time for the last 5 billion years, and for about the next 5 billion years. 5 billion years from now, if we're still on the Earth, we're going to have a big problem, because the sun is going to get a lot dimmer and a lot bigger and eat up all the inner planets. So we've got some work to do to find other places to live. But that's in the future. So that's the sun. The sun has never really been visited by a spacecraft, because you can't really get that close to it. But there was a spacecraft called Ulysses that has orbited the sun and studied it, and we learned a lot about it. And you can look that up, Ulysses, like the Greek hero. There's a couple of missions right now that are going on, or that are in development, that are going to study the sun. And we'll talk more about why the sun is worth studying as we get farther along. But again, we only have half an hour, so I'm going to move on. So what's the next planet what's the first planet closest to the sun? Exactly. Again, not a, is that too small? Can you read the M?
Yes.
Okay. So Mercury is a really interesting planet, because it's really close to the sun. It's pretty small. I think it's about 1/6 the size of the Earth. And it is so hot there, because you're so close to the sun, that not only is there no atmosphere, because the sun's heat has actually melted away all of the air, if there ever was any, the rock itself is actually being vaporized by the heat of the sun, and the closest thing to an atmosphere is a little bit of rock vapor. So imagine a rock outside, and the sun shining so brightly on it that it actually steams. Like it's not actually steam as in water vapor, but you see the material from the rock actually rising because it's so hot. So that's what we see when we look at what we would consider an atmosphere around Mercury. And that's really not a good place to live, although you would get a lot of solar power. But the spacecraft that we've sent to Mercury called Messenger, which I think is recently finished its mission. Messenger, if you look up a picture of it, I don't have an eraser, but basically, if you look up a picture of it, it's got a gigantic shield. I mean, in a very literal sense, it has a huge shield that's 2 or 3 inches thick, that has to be pointed at the sun at all times or the spacecraft will die. So the entire mission has to have the shield facing the sun to protect the spacecraft from the heat. And the solar panels have to be turned away from the sun, like edge on like this, or they get too hot. So for some of the time they're like this to gather energy, and some of the time they're like this to cool down. So it's really just about at the limits of our engineering and technology capabilities to send anything there in the first place. And the careers that make that possible are actually not traditional engineering and science. There's a field called materials science, which is about figuring out how to make materials harder or stronger or better or more heat resistant or what have you. And I would strongly recommend any of you to go into that field. I believe that is going to be a major field in the 21st century. I mean, it is already, but we've been using the same materials for 50 years, titanium, aluminum, and 200 years steel and copper. I mean, thousands of years for copper. But we're really running up against the limit of what all these common materials can do. And so we need people to figure out how to make them better at atom by atom in a very literal sense. So materials engineering, look it up. So that's Mercury. Mercury has no moons, and there's a lot of reasons why, a lot of theories about why that is. But basically, when you're that close to the sun, it's very hard for something small like a moon to stay in orbit around something big like a planet, because the sun and its gravity is just so strong that it would make the orbit unstable, meaning it's not going to last forever almost forever, the way most of the other moons go. Before I go on, is this working for you guys? Is this the right level of detail and stuff?
Yes.
I heard a no.
Yes.
Yes, okay. Okay, so that's Mercury. Venus. Venus. So Venus is bigger than Mercury, as you all know. Actually, I think you were in the front row. You said you were studying Venus?
Say yes.
Yes. So what's the most interesting thing about Venus, in your opinion?
But it has no moons.
Okay, it has no moons. It also has a really, really thick atmosphere. And it's so hot that the atmosphere actually makes the planet hotter than Mercury, even though it's twice as far away. So remember, Mercury has no atmosphere, meaning there's no air to keep the heat in. All planets are actually receiving a lot of energy from the sun, and they're also emitting a lot of energy. And that balance determines what kind of atmosphere you have on the planet. And it's also determined by the kind of atmosphere on the planet. So it's a big cycle. So Venus is hotter than Mercury. And we've sent, I think the Soviets sent 2 spacecraft, I think, and they both landed, or at least one of them landed. And it is really an amazing thing, because the temperature on the surface of Venus is like 500 degrees, hotter than the inside of an oven. And most of the atmosphere is horribly corrosive, sulfuric acid and other acids that you really don't want to be anywhere near. And so the spaceship that was sent there, it only lasted for about an hour. And this was a spaceship made of titanium, and all of the clear parts, like lenses and windows, were made of diamond, and it melted. So if you picture a diamond melting, that's how hot it was. It's pretty hard to imagine, because none of us have ever experienced anything like that. So it's very hard to explore Venus, because your spacecraft melts into a puddle almost within a few hours. So again, we need more material scientists to figure out how to make stronger metals that don't melt. The answer may actually be ceramics, but we'll see. So that's Venus. Venus is a really interesting place compared to the Earth, because it's about the same size. And a lot of people think that the Earth and Venus started off very similar, but Venus ended up with a very different atmosphere for a lot of different reasons that we could talk about for hours. So I'll move on. So then we get to Earth. Earth is Earth is pretty great. I'm on it. You're on it. Everyone who's ever lived has started off on it, and only about 400 or 500 people have ever left it, and they all came back. So they didn't all come back alive, but they all came back. So the Earth is a place to go, a place to be. Since we're talking about planets, typically we mean other planets, so we're not going to spend that much time talking about Earth. Earth science is its own subject. It's extremely important and interesting, but I think we can talk about the moon a little bit. So the moon, there's a lot of theories that say the moon was actually formed as part of the Earth when a huge rock hit the Earth about 5 billion years ago, and giant chunks of the Earth, that's better. Giant chunks of the Earth kind of were knocked away, and they ended up orbiting the Earth and cooling down and becoming the moon. So, and that's supported by a number of missions that we've sent to the moon that show similar rocks as we have on the Earth. And that's one of the ways we look at and we compare planets and moons, is we look at the distribution of different types of rocks, and that can tell us a lot about a place, even if we've never been there with people. So we've sent a lot of spaceships to the moon. It's the only place we've sent people. We tried to send 7 missions to the moon. 6 of them made it, and Apollo 13 came back. If you haven't seen it, the 90s movie Apollo 13 is an amazing movie about that. It's not completely accurate, but it gives you a sense of what happened. And to me, I think what's more important is to see how incredibly brave and clever human beings can be in an extremely challenging situation. And so I encourage you all to go watch that movie and then read about it. But movie's a great place to start. So we've sent people, we've sent all kinds of robots and orbiters to the moon. In 1961, we started trying to send things to the moon. It's pretty amazing, actually. The first one we sent completely missed the moon. And then the next 5 crashed into the moon. And finally, I think it was on the 7th try, we landed on the moon with a robot. And really, it was just a lander. But that shows you something really powerful, I think, about human spirit and ingenuity, is that we just keep trying until we get these things right. So one of the things that inspires me the most about space exploration is that part of it, the human side, the courage and strength and the teamwork and the hard work it takes to get this stuff done, because it's extremely difficult. But to me, it's also extremely rewarding. So I like that about it. So that's the moon. There's a number of different groups in the world that are trying to send stuff back to the moon right now. I hope they succeed. And I think within a few decades, there is going to be a colony on the moon. It may not be the U.S. colony, but there'll be a colony. So I think that's just my opinion. What's that?
I just asked, would they like to live on the moon?
Oh.
Kind of in the middle?
Well, I think that you all are about the right age that going to the moon or living on the moon may be more of an option for your age group than it has been for anyone else ever. So you've got that going for you. So I wish you all the best of luck in going to the moon someday. I hope I can go too. So let's see. So that's the moon. Now we can talk about Mars. So Mars, has anyone here studied Mars? Can you show me, raise your hands? Okay, great. So Mars is really interesting because it has a lot of very similar geology to the Earth. For many, many, many years, people thought there was no water, but it turns out there is water. There's a lot of ice. Excuse me. And on a very warm summer day on Mars, near the equator, it can get to be about negative 80 degrees, which is really warm for Mars. And it turns out there is actually very strong evidence of liquid water on the surface of Mars for a very brief amount of time, which is an extremely big deal because that, as far as we know, that's what life, among the things that life requires. So that was just recently discovered. There have been lots of rovers and other things sent to Mars. In fact, the very first attempt to detect life on another planet was on Mars in the 70s. And it was a really interesting mission that unfortunately the results were vague. They were ambiguous, despite the best attempts to make that impossible. It's really a crazy story. There were there were 9 possible outcomes, and only one of them was ambiguous, and that was the one that happened. And that was frustrating. And that actually made it very difficult to convince NASA to do another life detection mission for many decades, but someday we'll figure it out. So Mars also has 2 moons. Well, let me before I go on to that. So there's 3 rovers on Mars right now. Well, 4 of them. 2 of them are working. One of them is over 10 years old. It's called Opportunity. And the current one, or the big one, is called Curiosity. That's been there for a few years. And what they're doing there is they're looking for evidence of liquid water that was either there in the past or is there right now. And they're finding it, because what we see on Earth when we look at mountains and other places where there's been a lot of water coming and going, is it really changes the geology. So these rovers are looking at geology mostly and finding that it really looks like Mars used to have oceans and rivers and lakes a long time ago. So the big question then is, was there life, or could there have been life, or maybe even is there life now under the surface? So that's what the next rover is going to look for in about 4 or 5 years. Yeah. So Mars also has 2 moons. Now we get some really interesting stuff happening, because you're far enough away from the sun that very small objects can become moons. Very small objects like asteroids. So there's 2. Deimos and Phobos, and the theory is now that they were asteroids from the asteroid belt that got close enough to Mars to get stuck in orbit, and their orbit is decaying, which means the orbit is getting smaller, and in about 10 million years, I think, one of them is going to smash into the surface of Mars. And that would be a really interesting thing to see if any of us could see it, but somebody hopefully will be watching it, and that'll really be cool. Now, those moons are really interesting because they're big. I mean, they're asteroids. I think they're at least the size of Texas. And yeah, and they could be a very interesting place to land on with people before they go down to the surface of Mars. So just like leaving the Earth, the hardest part of any kind of planetary exploration is leaving the planet, because the gravity of the planet is holding on to you. So it may make sense to land people on the moons of Mars first before they go down to the surface. So let's move on to the asteroid belt between Mars and Jupiter. And I have to be careful with this so I don't pull it off the table. So just going to draw sort of some dots. So the asteroids are a really interesting resource, or maybe that's the wrong word. The asteroids are really interesting because they appear to be chunks of a planet that never quite made it, that never quite came together. So at the beginning of the solar system, there's this huge cloud of dust. And the gravity from the dust kind of forces all of the dust together, and it becomes a star, like I mentioned in the beginning. And sometimes when a star forms, there's a bunch of junk left over that becomes the planets. For the same reason, the gravity pulls them together. And then all this stuff is spinning around the star, and slowly things start to come together and move apart. And in the case of our solar system, you end up with a huge star and 8 or 9 planets, depending on how you count them, with a bunch of moons. Now, in the case of the asteroid belt, probably because of the strength of Jupiter's gravity, all those asteroids never quite made it together and formed a planet. So what we have in the asteroid belt is a bunch of asteroids bunch of pieces of rock, rather, that never made it into a planet, but that tell us a lot about how the solar system formed. And NASA just announced last week that, 2 weeks ago, I think, that one of the next missions is going to go to an asteroid that's entirely made out of metal, a giant metal asteroid, which is really weird, and nobody has any idea what's going on there. So that will be really interesting. That mission is called Lucy, I think. Yeah. Yeah, so that's the asteroid belt. I mean, there's a lot to talk about there, but we don't have a huge amount of time. So then there's Jupiter. So Jupiter is really interesting. It's huge. It has like 75 moons or something like that. But there's 4 moons that are particularly interesting, and they're called the Galilean moons, named after a guy named Galileo, who found them using a telescope he built out of junk 400 years ago. And the junk from 400 years ago was not nearly as good as our junk, and yet he made a telescope that could do this. So the moons are called Europa, Io, Ganymede, and Callisto. And each one of them is huge, I think at least the size of our moon. And NASA is going to be sending a lander to Europa because Europa has a giant ocean with more water than all of Earth under an icy shell. So there's like 20 miles thick of ice on the top of Europa, and then a water ocean. And the idea is that that is a really great place to look for life because it has water and solar and energy from the sun and all this other stuff. So that's really exciting. And starting at Jupiter, we get to a group of planetary missions that are really exciting to me because they are they're really big and they take a long time and they've gone a long way. So the first mission that saw Jupiter up close was called Pioneer, and then the mission Voyager saw Jupiter up close. And most of the photos from the early days, like 30, 40 years ago, are from those missions. And those spacecraft went so far away, they actually left the solar system. So all of the outer planets were first viewed up close by those. But to go a little bit closer in time, there's a spacecraft called Galileo that visited Jupiter and orbited Jupiter for 10 years. And that's where we got most of our up-close pictures and pictures of the moons. And the Galileo spacecraft was named after Galileo, who 400 years earlier had found he discovered the moons. So that was a really, really big deal. Jupiter is so large that when they ended the mission by sending the spacecraft into the clouds, basically imagine a school bus crushed to a soda can. That's how strong the gravity is at Jupiter. So really, really awesome and powerful stuff. So Jupiter, one of the interesting things about Jupiter is that we don't know if there's actually a rocky surface. We don't know if there's actually a solid surface under all the clouds. If you think about, first of all, Jupiter is 10 times bigger than the Earth. If you think about the Earth, the atmosphere, so think about an apple. Does anyone have an apple in the room by any chance?
No.
All right, well, you can picture an apple in your head. And if you think about the skin of an apple, and then the actual meat of the apple, the Earth is kind of like that, in that the atmosphere of the Earth is about as thick as, compared to the rest of the Earth, as that skin of the apple is to the apple, okay? You got that?
Yes.
So it's a few hundred miles of it's a few hundred miles thick of atmosphere, and then like a huge rocky planet. Okay, and that's good because that lets us have a ground to stand on, literally. On Jupiter, the whole thing is 10 times bigger, but it's actually much more like a beach ball worth of atmosphere with a pea at the center of it. So it's mostly gas. It's mostly ammonia and a bunch of gas like that. And we're not even sure if there's a solid surface. And if there is a solid surface, it might be made of metal, it might be made of rock, it might even be liquid metal because of how much gravity is there and how high the pressure is. We don't know. But if you look at the Earth, if you've ever been on an airplane and flown a long way, you'll notice that above a certain point, you're just looking down at the clouds, right? Well, on Jupiter, because the atmosphere is probably at least 10 times thicker, if you're above the clouds, you're in space on Jupiter. And there's actually so many different layers of atmosphere that you could have a storm here, a nice day here, and a hurricane up here, all on top of one another. And what we see with telescopes of Jupiter is just the top. And to see the different layers, you have to get closer and use other kinds of technology. But it's an amazingly complicated environment. If you think about it, again, if you think about on Earth, you have, let's say, a tornado. You don't have a hurricane on top of the tornado, right? But on Jupiter, you could. You could have a tornado that's as big as the Earth, and then a hurricane that's as big as the Earth on top of that. It's completely ridiculous. And it makes it very, very complicated, but we can learn a lot by looking at that. So let's move on. Oh, and there's I can't even keep straight the number of moons. It's at least 70. And on the Wikipedia page, actually, there's a really good discussion of all of the moons and what makes some of them interesting. So that's why I usually just talk about the 4 big ones. And those you can see, by the way, from your backyard with a telescope, which is one of the reasons why they're so, more people know about them, which is pretty cool, actually. And to think that 400 years ago, somebody was discovering them by looking through the same kind of tool. It's pretty wild. So then there's Saturn. And I'm drawing it down here because I use too much space, so I can't keep going that way. But obviously Saturn is farther away than... Oh, you know what I haven't said is how far away all these things are from the sun. So let's start over. Mercury is about 30 million miles from the sun. Venus is about 60 million miles from the sun. Earth is about 100. Mars is about 250 million. And these are averages because, they orbit the sun. So, but there's mostly circular, though. So the distance doesn't change very much. Jupiter is about 500 million miles from the sun. And Saturn is about 1 billion miles from the sun. So, a billion, yeah. It's very hard to imagine these things because the numbers are just so big. But, worth trying because it's pretty wild. So Saturn is a really interesting place that it's very big. It's almost as big as Jupiter, but it's much less dense. So actually Saturn is less dense than water, which means that it would float in a bathtub if you had one big enough, like a bath toy, which I think is pretty wild. And the most striking thing about Saturn is the beautiful rings. And there's a lot of different theories about why Saturn has rings and why Jupiter doesn't. Actually, Jupiter has one small ring that's very hard to see, but it's there. Saturn obviously has a very beautiful ring system. And there's actually some recent photographs of that up close by what's called the Cassini mission. Cassini is a spacecraft that's at Saturn, also named after a Middle Ages scientist. Well, not quite Middle Ages, but... and the rings of Saturn are made up of little bits of rock and ice. And at the moment, I cannot recall the current theory on where they came from, but we know where at least one of them came from. And it's connected to the moon. So Saturn has also like 65 moons or something like that. The 2 most interesting ones to me are called Titan and Enceladus. And they're interesting because they may be places where life could form, just like Europa and maybe Mars. So we'll start with Titan. Titan is a remarkably interesting place. It's a lot like Earth in that it has lakes and rivers and oceans and rain and clouds, and it has a full hydrologic cycle, which means the cycle of rain and water flowing and then evaporation and then rain again. But it's not water, it's hydrocarbons because Titan is about 300 degrees below zero. So at that temperature, things like methane and ethane actually become liquid. So the gas that maybe is used to heat up your school, although maybe you don't need heat in Texas, I don't know. The gas is a liquid. So you have a lot of the same features as the Earth in terms of rain and water and snow even, but it's not actually water that's doing it, it's hydrocarbons. And that's just really interesting and really cool. So because of that, Titan is a place where we think there might be life that's very different than life on Earth because there isn't water there, but there's all the same types of cycles as the Earth. So we would love to go there and check it out. Enceladus is a big slushy ice ball, and it is actually spraying water into space right now. So there are geysers. If you look up Enceladus, if someone could write down ENCELADUS. You can look it up later. Look up Enceladus geysers, and you will see there are actual water spouts from this moon that spray water into space. And one of the rings of Saturn is made up of ice that comes from the moon Enceladus, spraying it into space. So with Saturn, we come to the end of the planets that we have sent orbiters to, meaning a vehicle that orbits the planet for a long time and studies. past Saturn, we've only sent flybys, meaning spacecraft that fly by and take pictures or study it for one, for a brief amount of time. The reason is it takes so much energy to leave the Earth and then get going fast enough to get somewhere that it's very hard to actually slow down and stay somewhere once you get there. So these are some of the challenges of this century, like orbiting Uranus. So Uranus is mostly interesting because it's something knocked it over. So Uranus has a ring, but the ring is vertical compared to the rest of the solar system. And the theory is that something smashed into Uranus so hard a long time ago, it actually knocked the whole planet on its side. And it has continued to rotate like that ever since. And I think, also the moons of Uranus orbit backwards compared to the rest of the solar system, which is weird, and I don't think we have a good theory for that. But one of the reasons we don't know that much about Uranus is it's so hard to get to. It's at least 1.6 billion miles from the sun. And, we've only been exploring the planets for 50 years or so, for 60 years, and we just haven't sent an orbiter to Uranus yet. One of the reasons is that there's so many planets closer that it's become hard to justify the cost and expense of a mission way out to Uranus when there's so much we can learn from the other planets. But hopefully we'll get there. So Uranus, I can't think of anything particularly interesting about the moons, but there's a lot of them. Again, we don't know that much because we've only flown by once, and that was in the 1980s. So that's Uranus, and then there's Neptune.
Yes.
Neptune is pretty interesting. It's really blue. It's really pretty. There's not a lot of visible features on it because it's got I'm not sure I know why, but it has really, really fast wind. It has about 1,500 miles an hour of wind going around the whole planet all the time. And I don't think we know really why, except that on the Earth we know that incoming sunlight heats up air, which then makes it move faster. So the thinking is that is some kind of cycle like that is happening on Neptune, although it's so far away and the moon, and the amount of sunlight it gets is so low, we're not sure. And again, it's very hard to get to, so we haven't orbited it. We have never orbited it, and it's hard to study. It has a really interesting moon called Triton, not to be confused with Titan. And I believe the reason it's so interesting is that some of the photos that we have of it from Voyager show really interesting geology that looks a lot like the Earth. So as far as we know, that kind of thing only happens in places where there's lots of stuff going on, like sunlight and gravity and stuff like that. But again, I don't think we know that much about it, unfortunately. So that's Neptune, and then we get to Pluto, which I still consider a planet, even though it's officially not a planet anymore. And that's a really interesting discussion because human beings have known about some of the planets for 4,000 years, the ones you could see on Earth from without a telescope. And then in the 19th century, I believe was when, the 19th century is when Uranus and Neptune were discovered. Actually, Uranus was discovered. It was Uranus or Neptune. Neptune was discovered entirely by math, meaning it was not discovered by looking in the sky. It was discovered by someone doing the math to figure out where a large object should be that would explain why the other objects move the way they do. So people used math to discover, it was either Uranus or Neptune, I'm sorry, I can't remember. But basically they used math to figure out where in the sky a large object of a roughly, of a certain size should be in order to explain how everything else was moving. And then they pointed the telescope there and said, oh, there it is, which is pretty amazing. So that was probably done by a mathematician. That is extremely complicated math, but you could do it if you want to. So getting back to Pluto, Pluto has 5 moons. which is really weird because it's so tiny. I'm just going to write 5 here. I think we've known about one of them for a long time, but we only discovered 4 of them in the last few years. And I think, so there was a spacecraft that flew by Pluto called New Horizons. And if I remember correctly, 4 of the moons were discovered after the spacecraft had launched. So during the 10 years it took to get there, 4 moons were found. And I think that may have actually caused them to change the way they approached a little bit because the moons were there. And if you look at photos, you can just Google photos of Pluto. It's an amazingly diverse place that looks a lot like Earth with all kinds of different geology and stuff like that. So what we really found, and as we get to the end of our little session today, is the solar system is full of planets that are really alien, but also a lot like Earth. A lot of the same things we see on Earth are in other planets with sometimes different details like the temperature and the chemistry. But and then beyond the solar system, we've discovered 3,000 other planets around other stars nearby, relatively nearby. And so what it really looks like is that the universe is full of planets of all different sizes and types and stuff like that. But the closest ones that we can study now, there's a lot that's like Earth. So it's just an incredibly exciting area to see where we've come in just the last 50 years since the 1950s. And I genuinely believe that at some point before the year 2100, we will discover life somewhere else. Maybe just a bacteria or a plant or something, but there's just so much out there. And what little we know already has so much potential. I think we're going to find life pretty soon. And that's just my opinion based on everything we understand so far. But I think that's coming. So any questions? I'm happy to answer questions until you guys run out of time.
What's your favorite planet?
My favorite planet? I think Mars, because it's close enough we could send human beings there now if we wanted to. And there might be life. And it's also the only planet currently inhabited by robots. And I think we're going to see people there soon in the next 10 or 20 years. So to me, that's it's a hard question. It's a hard question. But yeah, Mars, I think.
Do we have more galaxies?
Yes. So we live in one galaxy called the Milky Way galaxy, and there are billions of other galaxies. So the Milky Way galaxy that we live in has, I think, 400 billion stars. What we're learning is that most stars have planets. So that's billions times billions of planets, and there's billions of galaxies. So yes, there is a lot out there.
What are the newest findings on Ceres?
On Ceres? That's a great question. Ceres is in the asteroid belt, and the mission Dawn is there. If I remember correctly, there was a photo recently taken of Ceres from the spacecraft that really we couldn't explain because it was super shiny, and there was this feature on the surface that we really didn't expect to see the way it looked. And I believe there's a conclusion that it's a sort of salty, icy, frozen mountain.
Yeah, so it says there is like water and there's weird white spots.
Yeah, the white spots. I think that the last I heard, they think it's a salty water frozen mountain or something like that. But I don't know. But you can look at, I'm sure that the latest information is available on probably the Wikipedia page, which is actually easier to read than the NASA web pages, I got to be honest with you.
Could there possibly be life in a different galaxy?
Absolutely. Absolutely. I mean, we're finding that obviously there's life on Earth. It looks like there's life maybe on Mars and maybe Titan and Enceladus and Europa, maybe. And those are 4 places just in one solar system. So given the billions of planets and billions of stars and billions of galaxies, I think it's very likely somewhere else out there, somewhere or sometime, there's life. And we may never find it, but I believe I think mathematically it's got to be out there.
Is there an Earth 2.0, and if there is there life on it?
Well, if by Earth 2.0 you mean another planet that looks a lot like Earth, I don't know. We found 3,000 planets. None of them really look exactly like the Earth, but a lot of them are similar in size or in distance from the sun or in number of moons or where they are in their solar system. I think somewhere out there's got to be another planet covered with life. I don't know if it's anywhere near us, if we could ever possibly find it, but we're certainly going to keep looking, and I hope you do too. I think we're more likely to find life on another planet that isn't really like Earth, but the life is still there, or the life is a little different, or maybe the life is completely different. Mostly because the diversity of planets is so high that, and we see life in so many different locations on Earth that probably will look a little bit different if we find it.
Why does Venus not have any moons?
Good question. So I believe the current thinking is that when you're that close to the sun, so moons orbit planets, right? So the moon goes around the planet because of the gravity of the planet. And if a really big object comes by, the gravity of that big object can actually mess up the orbit. So if, let's say, Jupiter came by the Earth, it would be very bad, but certainly the moon's orbit would be totally changed because of the gravity of Jupiter. So I believe the thinking is that the reason there's no moons in the inner solar system that is closer than the Earth at Venus or Mercury is that the moon, the sun's gravity is so strong there that no moon ever stayed, or no object ever stayed in orbit for a long time and never found what's called a stable orbit, meaning it just stays orbiting there forever or close to forever. So I think that's the answer, because of the gravity of the sun.
How do you build a spacecraft that can stand the gravitational pull of a planet?
The gravitational pull of what?
A planet?
Of a planet? Sure. So actually, we're really good at that because we build all kinds of stuff on Earth that is perfectly happy with Earth's gravity. The places we've ever landed are all smaller than the Earth, so we haven't had to build anything that could withstand a stronger gravity than Earth. So that's one thing. And if you want to build something that has to be a certain strength, well, that's what the field of engineering is all about, is looking at what your goals are and figuring out exactly the way you need to build something for it to be able to stay doing whatever it's supposed to do. Suppose it may just have to stand up like a building, or it may have to drive around. But that's what engineering is all about, is taking a set of goals and using our knowledge of the universe and physics and other sciences to build something. So that's engineering.
We may have a lot of engineers out here.
Yeah.
They're inspired, so.
Is there any other bigger planet than Jupiter?
No. In our solar system, Jupiter is the biggest planet, but what we have found in our other solar systems have bigger planets than Jupiter. Now, here's something to leave you all with. If you get to be about 10 times bigger than Jupiter, you're a star. So there's a limit to how big planets can get, and there's a limit to how small stars can get, and it's about 10 times the size of Jupiter. Once you get enough stuff together about that size, then fusion can begin, and a star can start to shine. So that's a pretty cool way to end the discussion.
Yes. All right, boys and girls, what do we tell Mr. Jeff for spending the morning?
My pleasure.
Thank you. We appreciate it. I think
Sure.
you've inspired a lot of our students.
Great.